So, math is a huge part of physics, and one of the big concepts in mathematics that relates directly to a lot of physics is trigonometry, meaning working with triangles and the math involved with that. So, here I have a triangle set up, primarily a right triangle. What I mean by right triangle is that one of the angles, this little one that I put a box on, is equal to 90 degrees, okay? And so physics involves a lot of math that involves right triangles. Namely, we want to be able to figure out how long the sides are and how big the angles are inside of it, okay? And so the tools we have to learn these things are called the trigonometric functions, or trigonometry, okay? So we have sine, cosine, and tangent, which are just functions you can plug numbers into, and they'll give you an answer back out. Only they directly relate to triangles, namely right triangles, okay? And so basically what we want to do is find a relationship between the opposite, adjacent, and hypotenuse sides of a triangle. Now the hypotenuse is the really long one. That's the longest side of any right triangle. It's always opposite the 90-degree angle. So if you have the box here to represent 90 degrees, the other side is going to be the hypotenuse. And then always in a triangle problem, we're always thinking of one angle. It could be this one, or it could be this one. In this case, I drew this one, the little theta symbol that we use to represent angles. I drew it in this corner, okay? So we're talking about this angle. Now when you look at the other sides, the side that is opposite, farthest away from this angle, is this side of the triangle. It's furthest away from it, and so we call that side the opposite side, okay? And then this side, this runs right alongside the angle with the hypotenuse. But this is not the hypotenuse. This is one of the, what we call the legs of the triangle, these two extra sides. So we have the hypotenuse, and the side right next to the angle is called the adjacent side, okay? And those three words are what we use to call each side of the triangle. So there's an H, an A, and an O, okay? And basically, we use these symbols to explain what our trig functions are going to be equal to. So if you take sine, okay, we represent that by sin of theta, okay? So if you take this angle, whatever it is, it could be 30 degrees, 45 degrees, anything less than 90, okay? You plug it in, that's going to be equal to something. And in fact, it's going to be equal to the length of the opposite side divided by the length of the hypotenuse. And so I'm representing that by an O for opposite and an H for hypotenuse, okay? Cosine is very similar. It's going to be another fraction. Cosine of theta is going to be equal to the adjacent side, or the length of the adjacent side, divided by the length of the hypotenuse. So the sine was O over H, and then cosine is A over H. And then the last combination is going to be for tangent. So tangent, if you take the tangent function and you plug in theta, you're going to get a number that's equal to the opposite side divided by the adjacent side. Okay, so for sine it was O over H, for cosine it was A over H, and for tangent it is O over A. Now, the common way to remember all of these fractions is with this word, SOHCAHTOA, okay? So SOHCAHTOA, okay, it sounds a little tribal, but it is a really good tool to break down this setup. So S stands for sine, O and H stand for the opposite and hypotenuse sides. So this function we've set up here, sine of theta is equal to O over H, is sine is equal to opposite over hypotenuse. Then cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent.